Okay, on this first one, they're asking us to find the domain of that function. Remember, when we're looking for domain, we look for two things that cause restrictions. We look to see if we have x's under an even root. I don't see any roots here, so no worries there. And then we also look to see, do we have x's that are in the bottom of a fraction? And I don't see any fractions here, so in that case, we would say our domain is all real numbers, which if you want to write it in interval notation, you write it from negative infinity to positive infinity, or if they allow you just to put the R, you can just say it's all real numbers using that scripted R. Remember, for x-intercepts, we have to set our original function equal to 0. Luckily for us, it's already factored, and so then you proceed by setting each factor separately equal to 0. So if x minus 2 is equal to 0, and I get x by itself, one of my x-intercepts is going to be the number 2, and they just have us listing them here as opposed to putting them in ordered pairs. And then if I take the other factor and I set it equal to 0, I would hope that that would factor further, but unfortunately it does not. So when that happens, you are forced to do the quadratic formula in order to find those intercepts. So our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So in this case, my b value here is a negative 4. If we take the opposite of that, it's positive 4. We have plus or minus. We have the square root. And we're going to plug in the negative 4. Be sure and put it in parentheses so you get that negative squared with it. Minus 4 times my a is 1 times my c is negative 8. And then all of that is divided by 2 times my a value of 1. So remember, your a is always in front of your squared term, and your c is always your constant. So then we simplify further. We have a 4 plus or minus the square root. Negative 4 squared gives me 16. And then when I do minus 4 times 1 times negative 8, that actually becomes positive 32. All divided by 2 times 1 is 2. So now I've got 4 plus or minus the square root of, that would give me a 48, all divided by 2. And I'm going to go ahead, they didn't ask for decimals, so I'm going to go ahead and break that down further. If you think about the number 48, it has a perfect square factor of 16. So if I write it as 16 times 3, then the square root of 16 will pull a 4 out of that radical. The 3 gets left in the radical, and you still are dividing by 2. And now notice that all of these coefficients, the 4 here, there, and then the 2 on bottom, they're all divisible by 2. And so when we reduce that, 2 goes into 4 twice. Plus or minus 2 goes into 4 twice. You still have your square root of 3. And then on the bottom, 2 goes into itself once. So my other x-intercepts, you have one x-intercept that will be 2 plus 2 square roots of 3. And then the other x-intercept will be 2 minus the square root of 3. And again, you pay attention whether they want them written as ordered pairs or they want them written as just to leave it in radical form or the x values like that. Okay, so the second one, they're asking me to actually sketch a graph, and they're giving me a lot of information about it. So let me first just start in general with a grid. All right, so notice they're telling me my domain is all real numbers except x equal 2. And so that is going to automatically make me want to see if there's asymptotes, because I'd want to get those on the picture first. And there definitely are. So they're telling me that I've got a vertical asymptote that's at x equal 2, which is why that was a exception of my domain. So I'm going to go ahead and show that. There will be no x's on the graph at x equal 2. And then I'll go ahead and put, they said I also had a horizontal asymptote at y equal 2. So I'm going to go ahead and show that as well. And so what graphs will do is they'll get closer and closer to those asymptotes at some particular point. Now, notice they gave me some specific points on the graph. You just have to recognize that when they say the f of negative 2 is 4, that means your x value is negative 2, your y value is 4. So there is a point, 1 point on my graph. When they tell me the f of 0 is 6, that means when x is 0, my y value is all the way up here at 6. And then when they say the f of 4 is 2, when my x is 4, then my y value is 2. Okay, and then the f of 6 is equal to 0, so when my x is 6, my y value is 0. So that's what I've got so far there with those points. And then, let's see. Oh, actually, you know what? I had a sign mistake. Hold on. I was wondering why that didn't. This should have been the f of 4 is negative 2. I knew something was looking kind of weird there when we touched that asymptote. So let's get rid of that point and let's put it where it should be. So when x is 4, my y value is down here at negative 2. That looks a lot better with those asymptotes. Okay, so now they're going to talk to me about increasing and decreasing. So notice that this is saying that your first derivative is positive, greater than 0, from negative infinity to 2. So that means the graph should be increasing. So if I start over here at negative infinity and I kind of play dot to dot with my points, that's telling me that graph should be going up from negative infinity to 2. It also says that we're increasing from 2 to infinity. So the reason there is the gap in there is because, remember, x did not exist at 2. So what that means is this piece here as well, again, if I'm playing dot to dot, that piece is increasing as well. And again, with asymptotes, the graphs tend to follow those asymptotes, so that gives you the shape by having those asymptotes written first. Now, the last part, if we've done everything else right, is really just something we should check. So this is a second derivative. It's saying that it's positive from negative infinity to 2. And so remember, positive second derivatives indicate that our graph should be concave up. And so let's just make sure that when we drew it from negative infinity to 2, we see something that is concave down. And that definitely does agree. And whereas here it's saying the second derivative is less than 0, which would indicate negative from 2 to infinity. So that should say when a second derivative is negative, you should see a piece of the graph that is concave down. And certainly when we look at what we've drawn from 2 to infinity, that definitely does agree.